Truth Seeker Learning here. Okay, today we're going to learn about the Pythagorean Theorem. Now, Pythagorean Theorem is named for an ancient Greek philosopher / mystic, and a mystic who's someone who is very much into prayer and communion with God and the divine. And he studied geometry. The Greeks studied geometry. They wouldn't have been able to build those beautiful, magnificent temples that still stand if it wasn't for the study of geometry. And Western civilization wouldn't be what it has been without geometry. But he studied geometry, and he realized this property that has existed forever regarding right triangles, only right triangles. Okay? And he discovered that if you square the two legs of a right triangle and then you add them, they equal the square of the hypotenuse of that right triangle. That's the theory, the theorem. So if we look at a right triangle, we see that this part here is called the hypotenuse. The hypotenuse is a couple of things. It's always the longest side of any right triangle, and it's always opposite the right angle. So that's how you can find it. It's always the longest side, and it's always the opposite the right angle. These are legs. They're called legs. It doesn't matter if this is leg A or B or B or A or B again. It doesn't matter. It doesn't matter. But those are legs, and that's a hypotenuse. You have to know. Okay? Now what we do is we apply it to a problem. So, and the problem being, we'll see here. Let's say, I'm going to put it here, actually. Say we have a missing value. So let's say this is 4, this is 3, and this is x. So let's say your teacher says, hey, here's a right triangle. The length of this side is 3 whatever, inches, centimeters, meters, it doesn't matter. Feet, and this is 4. That looks like a 9, but it's really a 4. Sorry about that. And this is missing. Find it. What is it? Okay, use your theorem. You can't go wrong. Let me show you how it's done. You could take either leg. I'm going to put 3 squared plus 4 squared equals x squared, which is really the c. Now what's 3 squared? 9 plus 4 squared, which is 16, equals x squared. Okay? Now we add 16 and 9. What is 16 plus 9? 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. 25, okay. Equals x squared. Now what do we do with that? Well, how can we solve for a variable that's squared? Well, what we have to do is get rid of the square. And what we do is we transfer it to the other side of the equal sign. And how do we do it? By making the 25 a radical. Okay, don't forget that step. All right, it'll become second nature and you won't have to worry about it. But I want you to understand that you're really transferring the x to the other side. Because that's done in other algebra problems, and you have to know how to do it. What's the square root of 25? Well, you should have your square roots memorized. And I'll go over them in another video. But square root of 25 is 5. So x is 5. So therefore, that hypotenuse is 5. Okay? Now that's pretty simple. I hope you're understanding. Now let's do another one. I'm going to use the same guy over here. Use the same triangle. And then we'll leave the theorem up here. And we'll just do it differently. Okay. So let's say I give you this again, right? And in this case, the teacher gives you the hypotenuse. It's 20. And then the teacher gives you one of the legs. It's 16. Okay? Now in this one, we might have to use our calculator. Or, to see if we can figure certain things out. But let's see. Now, in this case, we don't have we have the hypotenuse. We don't need it. We need one of the legs. So let's put this in. 16 squared plus b squared equals 20 squared. All right, now, what is 16 squared? Let's go to my calculator here. 16 squared is 256. I didn't have that one memorized offhand. 20 I do know. 20 squared is 400. Okay? So now I have 256 plus b squared equals 400. Now in this case, I have to combine like terms because this is an algebra problem, an equation. If you have been doing algebra with me, then you know this is an algebra equation. So combine like terms. So I'm going to combine the 256 and the 400. Sorry for my sloppy handwriting at times. Okay, now you can do a little subtraction here, right? 6 from 0 can't be done. Let's borrow from 0. Can't borrow from 0. He has nothing. So go to the 4, which becomes a 3. That becomes a 10, which then I borrow becomes a 9, and that's a 10. That was a little fast, but 10 minus 6 is 4. 9 minus 5 is 4. And 3 minus 2 is 1. Ah, it's 144. So b squared, I'll rewrite it here, is 144. Now I want to get rid of the squared, so I'm going to make it b equals radical 144. What's the square root of 144? Well, it happens to be 12. So b is 12. So this missing leg is 12. Okay? That's what this is used for. It's used in other things too, but this is the beginning of it, so for you. So let's just have you get it down first. And then you'll know what you're doing. Right? And that's always a good thing. Now, you know, I want to show you something actually interesting. I'm going to erase this here now because I think you know by this time what it is, and you can always go back in the video. But let's just say we have a situation where we have, see if I can get it here for you. A situation like this. Now I know it's not going to be a perfect drawing, but whatever. Right? Now, of course, this is a square. And we know, well, actually, no, this can't be a square. This is actually a rectangle. I know it doesn't look like it, but it's a rectangle. Because see, a square, all the sides are the same. A rectangle, opposite sides are the same. So this is not really a square. This is a rectangle. So maybe I should make it a little bit bigger. How about that? A little bit bigger to make it more accurate looking. How's that? Yeah. All right, that's a little better. There we go. Now it looks normal. Okay. And we need to find one of the sides. Well, you can do it with Pythagorean Theorem. You may have a problem like this. You may get something like this, and you might say, well, how can I do this? Use Pythagorean Theorem, because half of it is a right triangle. Well, both sides really are. That's a right triangle on this side, and then if you covered that, that would be the right triangle on this side. So let's do it. Let's use our Pythagorean Theorem. Well, we have hypotenuse, which is 9, and we have a leg. So it's 7 squared plus b squared, which is missing, equals 9 squared. That's the hypotenuse. Sloppy 9. 7 squared is 49, plus b squared. 9 squared is 81. Now again, we combine like terms. Minus 49. Minus 49. B squared equals 9 from 1. Can't be done. Borrow from Mr. 8, make him a 7, make him an 11. 9, 10, 11, that's 2. And then we go 7 minus 4 is 3, 32. B squared equals 32. Which now I'm going to turn into b equals radical 32. Now, a couple of things you can do here. First of all, 32 is not an even square root. Now, it depends on your teacher. You can leave it as it is. You can leave it as a radical, because that's what it is. It's radical 32. Or you can reduce it. You can reduce this radical. You've never done it before probably, but I'm going to show you. So if I have radical 32, I say to myself, what square root can I multiply to get 32? What square root can I multiply by another number to get 32? I'm thinking 16. 16 times 2, right, is 32, isn't it? Okay. And 16 happens to be a square root. All right. Square root of 16 is 4. Once you find the square root of it, it comes outside. Now it's a 4. And then I have a 2. So really, this is this. This is reduced. This isn't. Most of the time, your teachers want you to reduce. So I would advise reducing everything. But it all depends on what your teacher says. If your teacher says don't reduce, you don't reduce. If they say do, they do. But most of the time, you have to reduce. Let's do one more. And then we might have to end this video. It's getting long. So let's do one more. And then we can always revisit it if I have to. But at least you'll have somewhat of an introduction to Pythagorean Theorem. So here's another one. And go back to one like the first one we did. Now in this case, the hypotenuse is missing. So this is a classic one. So a squared plus b squared equals c squared. So the a squared now could be either the 6 or the 8. It doesn't matter. So I'll play a little game here and I'll switch them. So the 8 is going to be the a, and the b is going to be the 6, and the c is we don't know. So 8 squared is 64. The 6 squared is 36. C squared. 64 and 36 is 100. I just happen to know that, but let me show you. 6 and 4 is what? 10. 6, 7, 8, 9, 10. 100. See? That's 100 equals c squared. Now, what is the square root? Sorry. Let's get rid of the square first, and then we'll make him radical. 100, right? So, what is the square root of 100? It's 10. That is a really sloppy C. So, C is 10. That's what that missing side is. Okay. So let's end the video there. Truth Seeker Learning here. Please check out the website. Subscribe to the channel for more tutoring videos. I'm going to put a lot of them up, and I hope you are benefiting from these videos. Have a good day.